Hey everybody, welcome to the channel and thanks for checking out the channel, which is called Dude Tested. And today we're not only going to build the POTA pounder, but we're going to take it out into the field and utilize it to see how it functions. We'll talk all about it right here on the bench right now, but before we do, don't forget to like, comment, subscribe, unless your comment does happen to mention that you could use a trucker mount or a 3D printed mount to accomplish the same things. And in that case, I've already made the video below. Thanks for watching. Let's get started. These are all the parts we're going to need to build the POTA pounder, which will eventually look like this. As we go through building this, I'm going to go into detail that some people might feel is rambling or too much detail, but it's important I do that for two reasons. Number one, if you're a maker like myself, getting to watch how these things are built might give you different ideas on how you could incorporate something you see here into other projects. And number two, if you're new in amateur radio and this is still a little bit foreign to you, I hope that it will help you understand things a little bit better. So let's get started. We have our master main plate here. If we take a look at the master main plate, we'll see that it's pretty much the plate that houses everything from our antenna to our SO239 to our 4 radial wires, and of course our spike, or if we're going to be mounting it onto a tripod, something like our 1/4-inch coupler. As we build this out, we take our master or our main plate and we take our 3/824, which is the threading we're talking about, spike, and it should screw into the plate with no problem. Once we screw it all the way in, we could just leave it as it is, or we can put a nut on the top. Now, the reason I would say put a nut on the top is in the future, if you ever wanted to put something like spade connectors or even a ring connector on the top to add an additional 5th radial wire, which we'll talk about in a moment, you'd be able to do that. For now, let's just go ahead and kind of keep that on there and put that on there. And then we're going to let's work with our main plate and our SO239 connector, which will also eventually hold our antenna. We want to place it into the bottom portion of the plate. Notice when I do that, the outer part of the connector is touching the bottom plate, and that's good. What this allows us to do then is when we hook up our radial wires, the path will travel to the outer shield of the coax or the outer shield of the connector. And if we do this correctly, the antenna will be separate from the outer shield. If our stud here, 3/824, is touching the plate, then we short out the antenna, meaning there is no two separate parts of the antenna as there should be. So we put on this SO239 connector, and then we're going to use this little piece here. It's like a little spacer, but it's also non-conductive, so it helps prevent that post from touching the plate. Right now it can't touch the plate, while maintaining our outer shield to the radial wires. Now that we have that on, let's go ahead and put on our 3/824 coupler. And you might wonder, why did I use this L-shape kind of SO239 connector? Let me explain that to you. Let's say we go out to the field and we want to pound this into the ground. That would be great, except right now we don't have that 90-degree turn on the connector, which means when we plug in our coax, or probably a choke would be a good spot right here, we screw it in, and then as we go to pound it into the ground, depending on our coax, we might not have enough of an angle to get the POTA pounder closer to the ground. This might not be as big of a deal if you're using a tripod, but I did find the 90-degree angle connector to be very helpful. After installing our coupler, we could tighten down the SO239 connector so it won't move by using a 5/8 wrench, or of course I'm just going to use a channel locks, and tightening down that top coupler. Next up, we're going to install our radial wires. And I'm going to be putting these on the plate into these holes, which are threaded for number 10. But before I do that, I want to point out that radial wires have many different ways we could hook them up. We could use a bullet connector. For example, we could use a ring connector connected to a Vago connector, and that would allow us to rapidly connect and disconnect our radials. We could use power pole connectors, which I have shown off in the past, And there's just a lot of ways to do them. Today, I'm going to use some spade connectors. And this is really simple. It doesn't matter if we put them on the top or the bottom, but we're going to take these little tabs, which were originally made for batteries, and we're going to place them onto the plate. So they're touching the plate, and then we're going to screw in our M10s. Alternatively, you could screw in your number 10 screw before you put the radial spade connectors in place. With our ring connectors into place, we're going to screw down our nuts. One thing I do want to note is this step might take the longest, especially if you're using spade connectors, because you want to angle the spade connectors so they're facing out. Then what you want to do is you want to be able to back off the top screw so that it stays relatively tight. And then after that, you're going to take a 10mm socket, or in my case, just a wrench, hold it into place and tighten. This ensures that there's a good connection between the plate and the ring connector, and the ring connector, or rather the spade connector, doesn't move around too much. So for example, this one right here is a little bit loose. I'm going to go ahead and back off the top screw. And when I do that, I'm going to hold on to the spade connector. Now it feels like it's tight, and we could probably leave it just there, but for a little bit of extra kind of security, I'm going to take that 10mm wrench again, place it in there, hold that nut into place as I screw it down. Now we have the POTA pounder all built out. Not too bad at all. I just want to point out too that even though we have a really tight fit in between the plate and the SL239, I've tested this with many different Coax, and no matter what, the Coax seems to fit fine. I will also point out that if for some weird reason the outer shield does touch this plate, that's okay, because remember, our outer shield, or the outer part of the connector, is attached to the radial wires. For a better understanding of that, let's go ahead and hook up a multimeter. And we have our multimeter hooked up. And when I have this set to continuity, whenever a connection is bridged or there's full continuity between two things, we'll get a beep. Beep, beep. Now you might not be able to hear the beep, but you could definitely see on screen when the light turns green. And the reason I show that to you is the first thing that we want to do is we're going to touch that outer shield portion of the SO239 connector. Notice I'm not touching the inner shield. It might look like I am, but I'm not. And then we want to just make sure that we have continuity to all of the different male disconnects. The plate, but we don't have continuity up here where the antenna goes, because remember, we have it separated by that little piece of plastic. And so even if we went down here on the stainless steel spike, we would still have continuity. Pretty neat. And again, we just touched our outer shield here to our inner shield, no continuity. But if we go up here to the inner shield is what I just called it, but our center conductor, we have continuity. So basically, outside to radial plate, inside to antenna. We're good to go, and that gives us two parts of an antenna. Now, today we're probably going to use a telescopic antenna. Let's go ahead and get some calculations on how long our antenna needs to be for 20 meters, and let's get an idea of how many radials we need. Back on the bench. If we jump over to 73qrz.com, we can click on Tools. And once we click on Tools, there's a nice antenna calculator that's there. As I mentioned today, I want to operate on 20 meters. So 20 meters, let's just say we're going to operate somewhere around 14.325. That will give us a rough idea of how tall our telescopic antenna needs to be. I'm currently selected on half-wave dipole, but remember, we want a vertical antenna, and most vertical antennas that you see with a telescopic antenna on a device like this will be a quarter-wave vertical. There always is an option for a 5/8 wave, but we're going to stick with a quarter-wave vertical today. And it looks like our vertical antenna, or telescopic antenna, we'll need to put it to roughly about 16.34 feet. And we're going to need radials at 16.34 feet each. So I'm going to use 4 radials at about 16 feet. I now read some of these instructions and it says cut long and trim slowly. That's in reference to the antenna. The nice thing is we're using a telescopic antenna, so we won't have to worry about cutting anything. Our ground radials. For radials, or for verticals, more radials are better performance. 4 radials minimum, 16 to 32 is ideal. 120 is perfect. Now, I'm not going to go out into the field with 120 verticals. I'm only going to use 4 radials today, but because I am using the minimal, I will use 4 radials of 32 feet each. I would also like to point out that if we page down to the frequently asked questions, there's a little bit more detail in there. So how many radial wires do I need? More is better, but there is a point of diminishing returns. We talk about 4 radials being the absolute minimum. It will work, but we're going to lose about 3 dB. 16 to 20 radials is good performance for most stations. So if you're going out there to do a quick parks in the air activation, maybe you're going to only do 4 radials. But if you're going out to do maybe a long-term activation for more than like several hours, maybe you have 16 to 20 radials so that you get a little bit better performance. And we can continue reading on, but one of the things that it mentions here is the key principles from the DX Commander's research, and we talk about that. I want to point out that if we page down to the bottom of the screen, we can see a source to the article about how many radial wires do I need from the DEX Commander. So this becomes a pretty useful website. And now we're just going to go ahead and build our 4 radial wires at about 32 feet each. Today, while I build the radial wires, I've already actually built them, but I used BNTech Go silicone copper wire, 20 gauge. And you might be wondering why I used 20 gauge. I was out of 22 gauge. It should be fine regardless. And what I'm going to do is I'm going to put these on a winder. When I put them on a winder, I'm going to use the crossover, cross under kind of configuration. So I'm going over, under, over, under, over, under. And when I get to the end, at the end, I'm going to install a female 1/4 inch disconnect, or I might refer to it as a female spade connector. But this is going to allow me to basically rapidly deploy this onto the spike or the POTA pounder we just created. Now we could take our winder, and as we have that one disconnect on the actual spike, we could walk out. And if I'm holding it the right way, I could rapidly deploy my wire. So again, it's over, under, or a crossover configuration. All right, we're out here in the field. It's about 42 degrees today. The ground is relatively thawed, so this shouldn't be too much of a problem. But let's go out over here and POTA pound it. This looks like a good spot, right about there. And actually, I'm gonna give you a bit of a better camera angle. I think you should be able to see that okay. And I'm just gonna go ahead and I'm gonna pound it in. Now, depending on your soil, you may have a difficult time getting it pounded in. And at that point, maybe you use something like, I don't know, a shoe. Pound it in. There we go. You'll notice I didn't go all the way to the ground because I'm going to go ahead and put on my radial wires and my coax next. On the desk, we were discussing how you could have a Vago connector with a ring connector to be able to do your radial wires. We're going to go ahead and put this ring connector right on this 3/8 spike. And we're going to use this for one of our radials. Just like that. In the meantime, let's go ahead and get these other radials hooked up and we'll walk it all out. All right, everybody, we have our radial wires hooked up. As I mentioned, ring connector to Vago connector to BNTech Go silicone wire going out in one direction. And then the other 3, we have the 1/4 inch female disconnect. Now we have all of that hooked up. Let's go ahead and hook up our choke right here and then our coax, and then we'll get the antenna on. Let's go take a look though before and kind of see where we run out with our radial wires, what I've done with that winder. And because this is soft soil, I'm able to do that. As I just mentioned, we were going to put a choke in place. However, it looks like I forgot the choke on the counter at home, so good job me. But this will still work without a choke. And so we're just going to plug in our coax right now and run it over to the bench. Now, if you could imagine, I'm plugging this in on the side, but again, I mentioned it before, if I try to plug this in on the bottom, We do possess that capability of kinking or breaking or damaging this wire, which you might actually see in a moment when we check the standing wave ratio, because I have done it with this cable, and I think that this cable is partially damaged because of that. It's an important tip to know. Let's go ahead and get this screwed in. And with this RG8X coax screwed in, I'm just going to go ahead and kind of flatten this out a little bit and try to make sure it's relatively flat. We got our HRD25. Let's go ahead and get it screwed in to the plate. It should be fairly easy. Yeah. And I think I'm just going to screw it in or push it down a little bit more. There we go. And now 16.34 feet. I don't even know. Hopefully this will be... Can you see me? No. Probably right about there. Let's go ahead and plug in our coax. And good thing I brought batteries, I hope. Currently at 13.225 megahertz, we're at 2.53 to 1 standing wave ratio. And if we increase up to 14.225 megahertz, our standing wave ratio goes down to 1.6 to 1, which should be fine. However, if we go to 15.225, our standing wave ratio goes down even more to about 1.4 to 1. After 15.225, 16.225 becomes 2 to 1. So our dip is a little bit high from 20 meters. In order for us to make the dip go into 20 meters, we need a little bit more length on our antenna. I'll extend it out right now. And I would assume that if I add more radials, that I might be able to tweak the standing wave ratio down a little bit more. Right now at 14.225, I'm at 1.5 to 1. If I go to 14.325, I jump to 1.54 to 1. So I'm pretty well good in the voice portion. Less than 2 to 1, I'm okay with. So now the fun part is hooking up our radio and operating and seeing how the POTA pounder works out. Overall, it feels like a relatively quick install, a fun build, but does it work? Nav calling CQ Parks on the air from Park US 1012.
Kilo X-ray 4, Yankee, Quebec.
All right, Kilo X-ray 4, Yankee, Quebec. I have you at a 5x9, 59 here in the Park US 1012. My call sign, Whiskey 9, Fox, Fox, Fox. QSL?
QSL, I got you 5 and 9.
Thanks for the 5-9, Virginia. And thanks for helping me activate the park. Hope you have a great one. It's Whiskey 9, Fox, Fox, Fox. Parks on the air, QRZ.
Kilo Quebec 4, Golf, Echo Victor, Foxtrot.
All right, we'll start with the Kilo Quebec 4 station.
Kilo Quebec 4, Golf, Echo Victor, 5-9, Alabama.
Thanks so much, Kilo Quebec 4, Golf Echo Victor. I got that one confused now. You're also a 5-9 here into Northern Illinois from Whiskey Niner, Foxtrot, Foxtrot, Foxtrot at Park US 1012.
Thank you much. Good luck with the activation. Thanks for taking the call. 73.
73, thanks so much. Was there a station ending in Foxtrot? And QRZ.
Kilo Echo 2, Foxtrot, Juliet, Yankee.
All right, Kilo Echo 2, Foxtrot, Juliet, Yankee. Norman, I have you at a 5x4, 54 here into US 1012. QSL?
QSL, I have you at a 5-4 into Northern New Jersey. Thanks for activating. 73.
Thanks so much for helping me activate. You were my 10th QSO, so we're activated. 73 to you. Thanks so much, and QRZ.
Kilo Alpha 3, Mike Alpha Juliet.
Kilo Alpha 3, Mike Alpha Juliet. Lewis, I have you at a 5x9. Beautiful signal here in the Northern Illinois Park, US 1012. QSL?
QSL showing QSL. Thanks for that 5-8. I have you for 5-9.
2, 1. Okay. Hey, so let's see. We started the activation at 1554 Zulu, and by 1618 Zulu, we've gotten 40 QSOs. If I take a look at the map here, mainly all south and east of us, but I did get one in Arizona and one in Washington. 40 contacts in about 30 minutes. Not a bad day of doing parks. And the cool thing about this is I could rapidly, what's the word? I could rapidly get it all disassembled and thrown in the vehicle to go to the next park So, hey, thanks for watching. You got to see the POTA pounder out here today. Get an idea for how you could build your own quarter wave vertical antenna or your own kind of antenna mount as well. And I hope it helps out. Until next time, thanks for watching the channel. If you do like these videos, don't forget to like, comment, subscribe. And 73.